Where's my calculator? Oh, hey, welcome back to my fast paced series on the hardest digital SAT practice problems. Today, we're doing 3 questions on systems of equations. Let's go! Solve your math problems. Tap pause to try problem 1 on your own. As always, we start by using my what's the most important word strategy. So we jump to the question, we look for the word what, which isn't even in this problem. So we jump to the word which instead. There's really nothing too interesting in the question. It tells us it's a system of equations, but our eyeballs knew that just by looking at it. In this problem, the dream crushing sociopaths at the SAT were particularly angry because the question doesn't make sense, the answers don't make sense, but that's what they try to do. They try to get you so confused that you lose track of your skills and you don't even do the things that you actually know how to do. So don't fall for those tactics. When the words don't make any sense, I use a strategy called trust your eyes, trust your instincts. And I just do the math that I've practiced 100 times and hope that the words will make sense later. If you see a math problem that you know how to do, even if you don't understand the instructions, just do it. You're better off doing the problem than doing nothing at all. First of all, whenever you see a system of equations problem, the first thing you have to do is decide for yourself, is it an elimination problem or a substitution problem? So if it looks weird, it's substitution. But if everything is perfectly aligned, you want to use elimination. If it says y equals or x equals, that's a substitution problem. Well, this is clearly an elimination problem because the two equations are stacked on top of each other nicely, and the x's are lined up, the y's are lined up, and the numbers are lined up. A wise student once told me, if it looks weird, it's a substitution problem. If it doesn't look weird, it's an elimination problem. You can pick to eliminate the x's or the y's because they're both easy to eliminate. I'm going to eliminate the x's by multiplying everything in the top equation by 3. That gets us 15x minus 6y equals negative 21. When you combine the two equations, everything cancels out. Wait, what? And all of those months of practicing on systems of equations in school seem even more pointless than before. Whenever you get an equation that ends up with 0 equals 0, there's actually infinitely many solutions, which tells you the two equations are just copies of each other in disguise. Look back at the very first few words of the problem. What does for all real numbers mean? That sounds like maybe the problem has an infinite number of solutions. If you practice the SAT enough, you'll realize that this is an SAT classic. You spent years of your life studying systems of equations with solutions, only to show up to take the SAT to find a question without any solutions or infinitely many solutions. So, how do we find the right answer here? If you don't have your glasses on, those don't look like answers at all. The secret here is a strategy that I call alphabet soup. Whenever you see unexpected letters in the middle of your math problem, it's time to pick your own numbers. I like to say, the SAT is not the boss of me. So, what do you want to pick for N? I'm going to pick 10. I like 10 because it's easy to work with for multiplication. If n is 10, the first ordered pair is 20, comma 7. That's great. Well, what the heck does that mean? Well, it's an ordered pair. And one of my sayings is don't stare at ordered pairs. Just plug it in. So you put 20 in for x, 7 in for y, and the first equation. Do you think 100 minus 14 is negative 7? Let's try the next ordered pair. 10 is a little gruesome here. So this time I'm going to use 1 for n. If n is 1, this ordered pair would be negative 1, comma 1. Don't stare at the ordered pair, just plug it in. If you put in negative 1 for x and 1 for y into this equation, it does equal negative 7. I've never been so excited in my whole life. We should check the second equation, but trust me, it works too because the equations are just copies of each other. So, as a quick recap, if you see a math problem, do the math problem. Weird instructions usually make more sense later. Whenever you see a system of equations, decide immediately should you do elimination method or substitution method. Weird problems are substitution, and if it doesn't look weird, it's elimination. In our problem, everything canceled out. Whenever you get 0 equals 0, there are infinitely many solutions. And if there are too many letters in your problem, it's time to pick your own numbers and use the alphabet soup strategy and say the SAT is not the boss of me, and just put a number in and see how it goes. Now, tap pause to try problem 2 on your own. This isn't your normal system of equations problem either. As with all questions, I always start by asking, what's the most important word? Here, they aren't even asking you to solve the system of equations. The psychopaths want you to find a pair of perpendicular lines. What does it mean to have two perpendicular lines? The slopes of perpendicular lines are negative reciprocals. One goes up, the other does not. One is steep, the other is not. One has a slope of up 5 over 2, the other will go down 2 over 5. And they'll have slopes that are negative reciprocals. Sing it with me. The slopes of perpendicular lines are negative reciprocals. Okay, that was terrible, but hopefully it will help you remember that the slopes of perpendicular lines are negative reciprocals. So this was really a slope problem. The best way to find the slope is to solve both equations for y and get the equations into y equals mx plus b form. Solving the first equation for y, you have to subtract the 4x from each side and then divide by 5 to get y equals negative 4/5 x plus 4. The second equation is a bit scarier, but it's really just the same thing. You have to add ax to both sides, then divide by b, and you'll get y equals ax over b plus 11 over b. So the first line has a slope of negative 4/5. What would be the slope of the perpendicular line? Well, the other line has to have a slope of positive 5/4 in order to be the negative reciprocal, which means A is 5 and B is 4. If you've done these problems 1,000 times like I have, you realize that you just reverse the numbers and change one sign, and they will be perpendicular. So let's find the right answer. I'm pretty sure it's not C or D, so I'm going to try B. If you put a 5 in for A and a 4 in for B, This equation says 10x minus 4y equals 15, which will be perpendicular to the other equation because the coefficients are reversed and one of the signs is different. If you don't trust me, and maybe you shouldn't, you can solve each equation for y and verify that the slopes are indeed negative reciprocals. To quickly recap, the most important word was perpendicular. So it was a slope problem. So we solved each equation for y so that it would be in y equals mx plus b form. And since perpendicular lines have slopes that are negative reciprocals, and the first slope was negative 4 over 5, the perpendicular slope had to be positive 5 over 4. So A was 5 and B was 4. Then we tried using those values for A and B to find a set of perpendicular lines. We've got one problem left. If you just got a little smarter, please like and subscribe so you won't miss any of my videos. And most importantly, improve your SAT score. And don't forget to share with your friends. Now, tap pause to try problem 3 on your own. This problem is definitely a substitution problem because it looks weird. So we're going to substitute this first equation into the second equation and replace y with 0.25x squared minus 2x minus 5. Whenever you see an x squared in an SAT problem, it's usually another factoring problem. So we're going to bring everything to one side, set the equation equal to 0, factor and solve for x. However, some idiot put an A in the middle of our math problem. Normally, I would just say the SAT is not the boss of me and throw a number in there. Unfortunately, that doesn't really help this time. So, what do you do in a factoring problem when you can't factor? The quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Somebody sang a song about it. You don't want to hear me do that. Now, if you look at this question, you can see that the most important word is exactly 1 point. So, what has to happen in your quadratic formula if you're only supposed to get one answer? The number underneath the square root sign has to be exactly 0. That way, whenever you add or subtract, as required by the plus or minus sign, you will be adding or subtracting nothing, and you'll still have the same number either way. Do you know the name of the number under the square root sign? It's the discriminant. Based on all the new practice tests that I've researched, the discriminant is playing a more important role on the SAT math test than ever before. So let me give you a quick refresher on the discriminant. First of all, it's b squared minus 4ac. When it is positive, there are two real solutions. When it is 0, there is only one real solution. When it is negative, there are no real solutions. So, as it turns out, the discriminant has to be 0. So then this part of the quadratic formula disappears, and x is just going to be negative b over 2a. Do you recognize x equals negative b over 2a? It's the vertex formula. I just showed you all 3 formulas that you might need for quadratics in one problem. So make sure you have the vertex, discriminant, and quadratic formulas all memorized. You're welcome. After studying this test for years, I like to say that parabola problems are usually vertex problems. And once again, I'm right. Anyways, back to this problem. Negative b over 2a is 6 over 0.5. What is 6 divided by 0.5? What could possibly go wrong next? Did you say 3? If so, you're doing it wrong. It's 12. Wait, what? Yes, the answer is 12. How many halves does it take to make 6? It takes 12 halves to make 6, so the answer is 12. All right, if you've studied calculus, please raise your hand. Whether or not you have done calculus, you're still special. And you never need calculus on the SAT or after college. But can you think of how you could use calculus to do this problem? If so, please add your answer in the comments. Thanks for watching. I will see you in my next video, and a link to the hardest problems and the paper practice test is in the description. Please practice.